One alternative to using multiple 3-way and 4-way switches to control 277 volts high bay lighting circuits is to use a relay-controlled switching system. This method involves installing a relay with a 120 volts coil in parallel with the 277 volts contactors coils. The necessary components include a 120 volts relay with normally open and normally closed contacts, momentary push buttons, a 120 volts transformer, and appropriate wiring. The operation of the system involves connecting the relay coil in parallel with the coils of the 277 volts contactors. The momentary push buttons are wired to control the relay. Pressing any of the buttons will momentarily energize the coil, causing the relay contacts to change state. One of the relay contacts should be wired to maintain the coil's energization when any button is pressed. The other relay contact should be wired to break the coil's energization when the last button is released. The benefits of using a relay-controlled switching system are: firstly, it only requires one wire to each switch location, simplifying wiring. Secondly, multiple switch locations can be added easily without additional wiring complexity. Thirdly, it can be implemented with standard momentary push buttons, which are readily available. When installing this system, firstly, ensure the relay is rated for the current draw of the 277 volts contactors coils. Secondly, use a transformer to isolate the 120 volts relay coil from the 277 volt circuit. Thirdly, always follow all applicable electrical codes and regulations. In more detail, let's discuss the components involved in this type of system. The 120 volts relay is the heart of the system, and it needs to be chosen carefully. Firstly, you need to select a relay with a coil voltage of 120 volts, as this will be the voltage used to energize the relay. Secondly, the relay should have both normally open, often abbreviated NO, and normally closed, often abbreviated NC contacts. The normally open contacts are open when the relay coil is de-energized and closed when the relay coil is energized. Conversely, the normally closed contacts are closed when the relay coil is de-energized and open when the relay coil is energized. These contacts will be used to control the energization of the 277 volts contactors coils. Thirdly, the relay must be rated for the appropriate current. The relay contacts need to be able to handle the inrush current and the steady-state current of the 277 volts contactors coils. Consult the specifications of the contactors to determine their current requirements. It is always better to choose a relay with a higher current rating than is strictly necessary to provide a safety margin and ensure long-term reliability. Next are the momentary push buttons. These are simple switches that only make contact when they are pressed. When the button is released, the contact is broken. 3 or more momentary push buttons will be needed depending on how many control locations are desired. These buttons should be normally open, meaning that they do not conduct electricity when they are not pressed. The 120 volts transformer is used to step down the voltage from 277 volts to 120 volts. This is necessary because the relay coil is designed to operate at 120 volts, while the power source is 277 volts. A step-down transformer converts higher voltage to a low voltage. The transformer should be sized appropriately to provide enough power to energize the relay coil. Select a transformer with a volt-ampere, often abbreviated as VA, rating that is at least 20% higher than the volt-ampere rating of the relay coil. The wiring used in the system should be of the appropriate gauge, often abbreviated as AWGA, and type for the voltage and current levels involved. All wiring should be installed in accordance with applicable electrical codes. The following steps describe the operation of the relay-controlled switching system. The first step is to connect the relay coil in parallel with the coils of the 277 volts contactors. This means that one side of the relay coil is connected to one side of the contactors coils, and the other side of the relay coil is connected to the other side of the contactors coils. This connection should be made using appropriately sized and rated wire. The second step is to wire the momentary push buttons to control the relay. The push buttons should be wired in parallel with each other, meaning that one side of each button is connected to a common point, and the other side of each button is connected to another common point. One of these common points is connected to one side of the 120 volts power source, and the other common point is connected to one side of the relay coil. When any of the push buttons is pressed, it will complete the circuit, allowing current to flow through the relay coil. The third step is to wire one of the relay contacts to maintain the coil's energization when any button is pressed. This is done using a technique called latching. One of the normally open contacts of the relay is wired in parallel with the momentary push buttons. When any of the push buttons is pressed, it energizes the relay coil, which causes the normally open contact to close. This provides an alternate path for current to flow through the relay coil, even after the push button is released. This keeps the relay coil energized, and the 277 volts contactors remain closed. The fourth step is to wire the other relay contact to break the coil's energization when the last button is released. This is done using one of the normally closed contacts of the relay. This contact is wired in series with the 120 volts power source. When the relay coil is de-energized, the normally closed contact is closed, allowing current to flow through the circuit. However, when the relay coil is energized, the normally closed contact opens, breaking the circuit. This prevents the relay coil from being continuously energized, which would waste energy and shorten the life of the relay. Now let us consider the benefits of the relay-controlled switching system. Firstly, it only requires one wire to each switch location, simplifying wiring. In a traditional 3-way and 4-way switch circuit, multiple wires are required to connect the switches together. This can make the wiring complex and difficult to troubleshoot. In contrast, the relay-controlled switching system only requires one wire to be run from the relay to each switch location. This simplifies the wiring and makes it easier to install and maintain. Secondly, multiple switch locations can be added easily without additional wiring complexity. Adding additional switch locations to traditional 3-way and 4-way switch circuit can be difficult and require significant rewiring. However, with the relay-controlled switching system, adding additional switch locations is as simple as wiring another momentary push button in parallel with the existing buttons. No additional wiring complexity is involved. Thirdly, it can be implemented with standard momentary push buttons, which are readily available. Momentary push buttons are widely available from electrical supply stores and online retailers. They are inexpensive and easy to install. In contrast, specialized 3-way and 4-way switches may be more difficult to find and more expensive. Now for some additional considerations to ensure the relay is rated for the current draw of the 277 volts contactors coils. The relay contacts must be able to handle the inrush current and the steady state current of the contactors coils. Consult the contactor specifications to determine these current values. Select a relay with a contact rating that is at least 125% of the expected current draw to provide a safety margin. To use a transformer to isolate the 120 volts relay coil from the 277 volt circuit, this isolation is crucial for safety. The transformer should be a step-down transformer, converting 277 volts to 120 volts. Ensure the transformer is properly grounded and installed according to code. Finally, follow all applicable electrical codes and regulations when installing the system. Electrical codes vary by location. Consult your local electrical code for specific requirements. All work should be performed by a qualified electrician. Electrical work can be dangerous and should only be performed by those with the necessary skills and experience. As a final thought, consider adding surge protection. Adding surge protection to the 120 volt circuit can help protect the relay coil and other components from voltage spikes. A surge protector can be installed in the 120 volt circuit near the transformer. With the relay-controlled switching system, it's important to understand the principles of operation and all safety precautions. Make sure to consult a qualified electrician for installation.